Our last topic of this video is generic methods. I probably should have warned you in one of the early segments in this video series that with a name like Syntax 1, this is not the most exciting lecture. And in fact, these three videos, this one, Syntax 2, and Syntax 3, they're useful, but they're not like, oh wow, that's beautiful. They're more just like, oh, okay, that's what the Java designers decided to do. So sorry it seems a little arbitrary, but we've got to learn it. So in this case, what we're going to do in order to understand generic methods is we're going to create a class called mapHelper. That's going to have two methods. One of them is going to be called get, and that method takes a map61b and a key, and it returns the value corresponding to this key in the map if it exists. Otherwise, it will return null. Now that's unlike the ArrayMap's native get method, the thing actually built into it, which will crash if the key doesn't exist. In fact, if we look at ArrayMap, we'll see that get, it just gets the index, and if it doesn't exist, it'll try and return the -1th item, and it'll crash. So mapHelper is going to try and do better. Now this is terrible class design. Really what you should do is fix your ArrayMap class, but for the sake of argument, just for pedagogical reasons, we're going to build it this way so that we can do it. The next one we're going to write will be called maxKey, and it will find the max key in a map61b. So let's start with the get method. So in this case, I have a little exercise, and we'll just jump right in. So if we go to mapHelper class, we can delete these comment marks, and this will now set up this test. We're going to use test get to make sure that get works, but we haven't written get yet, so of course the test does not compile. It's saying doesn't exist. Now if we look at what's going on here, it looks like mapHelper.get is supposed to be a static method because we're invoking it using the class name. So we'll say public static, and then we'll think, okay, what's it supposed to do? It looks like it returns an integer, and it's called get, and it takes an array, or it takes a map61b of strings to integers. We'll call that, I don't know, string integer map. And then we will do a key, k, or not a key, k, a string key. And then we'll do some code and return something, and we'll get there in a bit. Now before we even get there, actually the interesting part of this is not the code, it's the signature. So this code right now, you'll notice it's compiling, but this get method doesn't do what it's supposed to. It's supposed to work on any map61b. You give me any map61b and it should work. It shouldn't be a string integer. So how do we do that? Well, maybe we try and do something like v, k, v, k. But we'll notice that it doesn't compile, it's red. And in this case, it's saying, I don't know what you mean by v or k. I mean, these are just arbitrary symbols. As far as Java cares, I just wrote potato and like sauce. All right, it's hard to remember which one's which. Okay, but maybe I'll pick some different words. How about, it may as well be vanadium and ketchup, right? Like those are just meaningless symbols. So the question is, how do I actually get that to work? Well, our trick before is we go up to the class declaration and we put, I don't know, ketchup, vanadium up there. But the problem with this approach is that this is just not the right idea. Remember, the way these work is that when someone instantiates a mapHelper, they're going to pass along actual type arguments that will go and fill these in. But nobody's ever going to instantiate a mapHelper. We're not doing new mapHelper string integer or something. That doesn't make sense, right? We don't want to do that. So what we're going to try and do here is avoid the need to make the class generic. Instead, we're going to make the method generic. So it's actually a pretty easy thing we do here. Instead of putting it up here, we just stick it right after the word static, and now it'll work the way we want. So for the purposes of this single method, this ketchup and vanadium, it applies only to this tiny scope. And that's very different, okay? Just to compare and contrast with ArrayMap, where the KV goes up at the top and it's shared by the entire program everywhere. Here, it applies to only that single method. Now, I don't like ketchup and vanadium, so I'll go with KV, V, K, V, K. All right. So that is our get method, and now we'll write it. So at this point, I need to actually get the value back, so I can do the following. We will do if sim contains key, then we will return sim.getKey, and we need to add some parentheses. And if it doesn't contain it, we'll just return null. And then here we'll run our test. Now this is a very terrible test because it doesn't actually test the case where the item doesn't exist, but let's run it anyway. So this is mapHelper, and we run our test, and it passes. I don't know, let's make the test even better. So let's do mapHelper.get in this case, and we'll do an assert equals null that. Okay, and we'll put this back up top. So this will also check the null case. Just make the test a little better. Okay, so we run it, and it seems to work fine. Good. Okay, so that's the test get method. So again, the special thing here was making a single method generic as opposed to an entire class. So now let's write test max key. So in this case, we're gonna move on to, well, actually, I'll debrief real quick and then we'll do the program. So the key point here is that I set up the type parameter definitions in the actual method declaration. I put them after the word static, and in this case, zerp is just who knows what. And here, the difference is that rather than specifying at runtime which types we want, we don't put map helper string integer. It automatically infers it from the type of object passed. So that's kind of nice. Now, you're probably getting a little dizzy about types. You won't have to go too much deeper than this in 61B, but if you're curious, there's plenty more to learn about types, and there's crazy things that can happen. And let's see just one more for now. So in the next case, we're going to do max key. So again, it's an exercise you can try, and so now let's go and do it. So in max key, I'm again going to uncomment this, and I had it commented out because it won't compile otherwise, because we do not have a max key method. So what might that look like? Well, max key is supposed to return the max of all keys. And if we look at what it does, okay, well, again, we'll do the hard-coded string integer trick again at first. And we'll say, okay, so we have a method, it's static because we're invoking it using the class name. It returns something of type string. The method is named max key. It takes an array or a map 61B of string integers. And we'll call this thing map string integer. Okay. I don't know why we called it sim before. Whatever. Okay. So in this case, this code right here, if we return null, it should compile everywhere. But again, as before, we don't want it to be for only strings and integers. So we already know how to deal with that. So we can simply say kv. In this case, this string is our k. This is kv, and we should be good to go. So let's try writing our code, and we'll do the usual stuff you might imagine. So here, we want to get back a list. We need to go through all the keys, so we'll get a list of keys, which will be the key list, which is equal to msi.list. It's a terrible name now because it's just a map, so I guess I'll call it map. Single letter variable names aren't necessarily great, but I'll call it map. Okay. Map's fine. So we get a map, we get the, what do we call this thing, keys, and then we will go through that key list. And we'll say, well, key largest equals key list dot get 0, and then we'll just go through each element of the key list. Actually, we can just do for k in key list, if kk key list. If k is greater than largest, then we'll say largest equals k. And we run into that same issue we had before, which is you cannot compare using greater than arbitrary objects. Also, I'll return largest. So we've already run into this issue before, and what do? We said k.compare to largest is greater than 0. Still, though, compare to does not work with k's. And that's true even though we're giving it an array map from string integer. Strings have a compare to, but it's not working here. And the reason is that, think about the compiler. All the compiler knows is that somebody's going to give me k's. And maybe somebody gives me dogs and they don't have a compare to method. So what we need to do is somehow deal with that fact. So ordinarily, what we would do is we would specify somehow that this is a comparable or something. And so the syntax for that in Java is we say k, not just k, but k extends maybe our comparable. Now that would be okay, except for the fact that our comparable is something you and I made up. It's not part of this package. So we need to use the built-in Java comparable class or interface. Now, of course, comparable itself needs to have a generic type parameter specified. So this is where it gets a little messy. So if you don't just want things that are comparable, but you want k's that are comparable to other k's. Okay, so we end up with this rather ugly declaration for our method. But in this case, it should work perfectly fine. I'll talk more about it in a moment. So let's just see if it works first, and then we'll discuss in a little more detail. Okay, we run it. One test passed. Actually, I want to run all tests just to make sure we didn't mess something up. I think I ran array map. So in this case, we ran both of our tests, and it works swimmingly. So let's debrief a little more what this is about in the next video.